Hello everyone. In this video we are going to see a problem in power electronics. The question is, the waveform shown in this solid line is obtained by clipping a full wave rectified sinusoidal shown dashed. The ratio of the RMS value of the full wave rectified waveform to the RMS value of the clipped waveform is dash. Round off to 2 decimal places. The waveform is given here, in which the dashed line shows the full wave rectified sinusoidal waveform, and the bold line shows the clipped waveform. It is given that the output voltage waveform is given, and we need to find out the ratio of the RMS value of the full wave waveform to the clipped waveform. So we need to find out the answer and fill that answer. So this is a numerical answer type question. The solution of the above problem is given here. We can find out the RMS value of the clipped waveform by using the formula, that is square root of the area of the squared waveform. If you take that square root of that waveform over a full cycle, then we will get the RMS value of the clipped waveform. That is, we have to find out the area of the squared waveform for a complete cycle, and then we need to get the square root of that. So if we do that, we can find out the RMS value of the clipped waveform. So the formula to find out the RMS value, it is given here. We need to get the squared waveform. So from 0 to pi by 4, we have Vm sin omega t. The waveform follows Vm sin omega t. If we refer the waveform from 0 to pi by 4, the waveform, it follows the sinusoidal waveform. So we can represent this sinusoidal waveform as Vm sin omega t. So squared waveform will be Vm square sin square omega t. So from 0 to pi by 4, and then also from 3 pi by 4 to pi, we have the waveform which is following the sinusoidal waveform. So for these two, we can write it as 2 times integration from 0 to pi by 4. We can represent the waveform as Vm squared waveform as Vm square sin square omega t. And then from pi by 4 to 3 pi by 4, the output voltage, the clipped voltage, it follows, the voltage is equal to 0.707 Vm. Square of that will be 0.707 Vm whole square. So if we integrate this waveform and that divided by, if we divide that by pi, that will give you this area of the squared waveform. And if we take the square root of that, then we will get the RMS value of the clipped waveform. So that is what it is given here. So 1 by pi within bracket 2 times 0 to pi by 4 Vm square sin square omega t plus pi by 4 to 3 pi by 4 0.707 Vm whole square t omega t. So if we find this one and take the square root, we will get the RMS value of the clipped waveform. So the next step will be this one. So Vm square sin square omega t, we can substitute as 1 minus cos 2 omega t by 2, and then we can integrate this Vm square, and after integration and after substituting the limits, we will get the final answer after substituting the limits as square root of, that is 1 by pi Vm square pi by 4 minus 1 by 2 sin pi by 2 plus Vm square by 4 into pi within whole thing divided by pi, and we need to take the square root. If we do that, we will get the clipped waveform RMS value as 0.5838 Vm. So this is the clipped waveform RMS value, and we know that for a pure sinusoidal waveform, the RMS value will be 0.707 Vm. So the ratio of the RMS value of the sinusoidal, that is a rectified sinusoidal waveform, to the clipped RMS value of the clipped waveform will be 0.707 Vm by 0.5838 Vm. So Vm and Vm will get cancelled out each other. So final value we will get it as 1.21. So the required answer will be 1.21, which we need to fill in the fill in the blank. So this is the required answer. Thank you.